So here's my free body diagram where I show that the force is acting on 45 degrees, dividing A on AY and AX. Then I just did trigonometric properties here to get the x part of the 2.5 kilonewtons on 60 degrees, and also for the y part. Then I put by, because in the image we can see that it's not that it has this thing. That means that it's only making force on the y-axis. And at last I just put a force CD acting here, and this is my free body diagram. And my calculations that I did was f of x equal to 0, which got me to this equation. And since there's only ax and the force acting here and the force of fcd, that's it for that part. And then for fy, I used the ay, the force acting here, and the by, and that was basically it. And the last thing was momentum. And the thing that I did is that I use FCD as my reference, which is the point that has all perpendicular axes to the forces acting on the system. So basically we have one negative AY because it's going up, and I decided that clockwise was going to be negative. So from here we have the 10 meters, it's here, and then we have the other force that it's at 6 meters acting counterclockwise, so it is positive. And last, the AX, which we have here our point, and it's at 3 meters of distance, and it's acting to the right way, so it is also counterclockwise, and that's positive. Doing that, we have a whole system of equations where we can obtain these answers. And to prove it that it's a system that it's in equilibrium, I just add the forces on x, which add to 0, and also the forces on y, which add to 0, which it means that this has to be the right answer. And the only thing that changed was that I put my FCD right, and it was negative, so I know it was actually left. And that's it.